This is lesson 4.5, solving rational equations. So we've done a lot of expressions. If you notice, we haven't had an equal sign yet in any of our problems. Okay, so now we're going to actually do use an equation. This first part is a review of Algebra 1. Okay, so this is, oh my goodness, 4.5, solving rational equations. If you're looking at problem example number 1, remember yesterday we were trying to get things to have the same denominator, but that was if we were adding and subtracting. Here we have an equal sign, so this looks like a proportion. You guys remember proportions from Algebra 1? How do you solve a proportion? Does anyone remember how you solve a proportion? Good. You're going to cross multiply and then set them equal to each other. So in example 1, if I cross multiply these, I'm going to do 7 times x equals 4 times x minus 6. This is nothing new to us. We've done this before. We know how to do this. We're going to distribute like normal. 7x equals 4x minus 24. We can solve this now. Get your x's to one side. So we're going to subtract 4x over. Gives me 3x equals negative 24. Negative 24 divided by 3, negative 8. Today we have to make sure that we check that our answer for x does not give us 0 in the denominator. If that happens, then it can't be a solution. So if you look at the problem up there, if I put a negative 8 in either of the denominators, if I put a negative 8 over here, that's going to give me negative 14. That's okay. If I put a negative 8 over here, it's just a negative 8. So I don't have a 0 in the denominator when I plug a negative 8 in. So we're in good shape, which means x equals negative 8 is an answer. All right, let's do number 3. Okay, so you're going to cross multiply. Remember, r times r is not 2r. Good, it's r squared. So I have r squared equals 4 times r minus 1. All right, what do we do at this point of our problem? Set it equal to 0, Lexi said. The easier thing is to move r squared over, but what do we always want to remember about our quadratic term? Say that again, Ryan? Keep it positive. So we're actually going to move the 4r and the negative 4 over. Okay? So when I move it over, I have r squared minus 4r plus 4 equals 0. So I move the 4r over, which becomes negative 4r, and I move the negative 4 over, which becomes positive 4. So then if I'm going to x factor this, remember how I told you at the very beginning of the term, factoring never goes away? Never goes away. Dalton says negative 2, negative 2. Can we take the shortcut here? You can, right? So this is just r minus 2, r minus 2 equals 0. Then what did you say, Leanna? Then we kind of split them apart, right? R minus 2 equals 0, r minus 2, well, I'm getting the same answer, right? So r is 2. Let's do a mental check, though. What happens when I plug a 2 into the denominator? When I plug it in over here, I get 2 minus 1. Dalton was just seeing if we're paying attention.
And
2 minus 1 is 1.
Oh.
You
right.
silly. And then if I plug it in over here, I just get 2. Right? So it's okay. I'm not getting 0 in the denominator. So r equals 2 can be an answer. Are you guys okay with this? Do we need to keep doing these? The easy ones? Okay. So let's switch over to the back of our notes now, page 20. This is where things get a little bit hairy. Not hairy scary, just a little bit trickier. Okay? So we talked yesterday about getting a common denominator. We have to be able to have a common denominator because if you notice, all on this first page is just 1 fraction equals 1 fraction. On the second page, though, we have 2 or 3 fractions in our problem. 3 or more sometimes. Okay? So if we're looking at number 7, what is the common denominator between 3, n, and 6?
There is 18.
Oh man, we need to remember how to do fractions. Okay, what number do all 3 of those numbers go into?
None, because it's
Stop.
n.
Okay,
1.
6. Right? They all 1 because there's a 1 in front of the n, right? There's a 1 in front of the n. So I hear what you're saying about the n. But 3, 1, and 6 can all go into 6. We can agree with that?
Yeah.
Okay. And then they all need a what, Taylor? What were you saying?
They all need n.
They all need an n. So 6n is going to be our common denominator here. Okay? So we know that we're going to put LCD is 6n. So I want you, this is going to be a little bit of writing today. Okay? So I want you to follow along because then you're going to see we are clearing the fraction. Because if you multiply each of these things by 6n, you're going to clear the fraction, which you guys have done with Miss Carolyn for sure. Okay? So if I multiply this first one by 6n, put 4/3 in parentheses here. Then if I multiply this up, the next one by 6n, 7 over n, equals 6n times 1 over 6. So I just multiplied each of these by 6n. Not 6n over 6n, because that would just be 1. Okay, and I don't want it just to be 1. I want to actually clear my fractions out. So look at what happens when we start to clear this fraction out. 6 and 3 can be divisible, right? That 6 turns into a what? 2. So then I have 2n times 8. I'm sorry, times 4. Sorry, that should be a 4 there. You guys see where that came from? 2n times 4. What about the second fraction? What's going to cancel? The n's, right? So then I have 6 times 7. What about the next, on the other side of the equal sign? What cancels? The 6's. So I just have n times 1. Okay, so now let's simplify everything. I have 8n minus 42 equals n. Notice all my fractions went away when I multiplied by the least common denominator. Can you solve this problem? You can, right? Let's move, since we already have a variable on the right side, let's move 8n over to the right side. So if I subtract 8n, I get a negative 7n. And then if we divide by negative 7, we get n to be 6. Before I say that 6 is an answer, what do I have to make sure? What? Put it in for your variable in the denominator so that you don't get 0 in the denominator. And the only place it can go in for the denominator is here. And if I plug a 6 in to n, it's just 6, right? Which is okay. So that means that n equals 6 is my answer here. All right, number 8. What do you think is the common denominator between k and 2? Just 2?
2K.
2k, right? So our LCD here is 2k. So we're going to do it again the same way we just did the other one. We have our 2k times 3 over k. I know this seems like a lot of work, but this is so that you're going to keep it straight. Okay? So all I'm doing is multiplying each one of the terms by 2k. That's all I'm doing here. So Cedric, in the first fraction, what's going to cancel? The k's, right? So then I have 2 times 3. Braxton, in the second fraction, what's going to cancel? The 2's. So I just have minus k times 1. Olivia, in the second or in that third fraction, what's going to cancel? The k's. So I have equals 2 times 12. Let's go ahead and simplify this.
Oh, you're using the cancellation method, right?
I'm clearing the fraction.
How did you, I know I'm jumping back to 7 here, but how did you cancel the first one when it's literally a 6?
It reduced. I didn't cancel all the way. 6 divided by 3 gives me this 2 out here. So I still had that 2 there. And so I did, that's why I did 2n times 4, not just n.
Okay, so you divided, you divided the 6 by 3.
Yes.
Okay, that's, sorry.
So I'm getting, if you subtract 6 over to the other side, you get negative k equals 18. Divide by negative 1, k is negative 18. Again, before we decide that this is an answer, we're going to double check our k's in the denominator. If I plug a negative 18 in here or here, it's fine, right? It's going to work. It's going to stay negative 18. I just can't have 0, so that's going to be my answer. Right, ready to take it up a notch? All right. Here we go, number 9. Oops. Okay, this is very similar to what we were doing last time, okay? Yesterday. So p squared minus 4, what does that factor to?
P plus 2, P minus 2.
Good. P, so that's going to be my LCD. Write that over there to the side. P minus 2, P plus 4. Remember, we're only multiplying plus 2. Remember, in the examples 7 and 8, we only multiplied the numerator, right? Because we always canceled something out in the denominator. So let me just show you really quickly what happens. Don't write this down, just watch. If I do p minus 2, p plus 2, times this first fraction, p over p minus 2, what's canceling here? Okay, so isn't it fair to say, if I just look at what this fraction is missing, right, what's the denominator missing? It's missing a p plus 2, right? Would you guys agree with that? It's missing a p plus 2? Isn't that what's left to multiply by? Is that p plus 2? Okay, so instead of writing this p minus 2, p plus 2 out every time, and then canceling, and then seeing what you have left, whatever the denominator needs is what you're going to multiply the numerator by. Okay? So in this example, the denominator needs a p plus 2, right? So that means we're going to multiply p plus 2 times the numerator. Okay? Because again, remember what I just did? I don't know why it's doing that. Okay, so we know that each of them need a p plus 2, p minus 2. If you look at the second fraction, it doesn't have anything, right? It has nothing in that denominator. There's nothing to cancel with.
I didn't even know there was another fraction.
Plus 2. So that means I need to multiply p plus 2. Can we simplify p plus 2, p minus 2 to p squared minus 4?
Why not?
Nope. Okay. P plus 2, p minus 2 times 2, right? There's that 2. What about the 8? If I do p plus 2, p minus 2 times 8 over p squared minus 4. All right, so look what I did. I just did a p plus 2, p minus 2 times each thing. Okay? We haven't canceled yet. I just did a p plus 2, p minus 2 times each thing. All right. If we're looking at our first fraction, my p minus 2 cancels with my p minus 2, correct? So I'm left with p times p plus 2. What about the second group? Can the second group cancel with anything? There's nothing for it to cancel with down here, right? There's nothing down there. So that means this 2 is getting multiplied times this and this. But didn't we say this whole thing together is p squared minus 4? Right? So instead of splitting it up around p plus 2, p minus 2, let's just do 2 times p squared minus 4.
Could we follow the steps of it in the expanded form?
Mm-hmm. Look at the last one. I have an 8 over p squared minus 4, but didn't we say that this is really p squared minus 4? So this whole thing cancels with this whole thing? So we just have an 8 left. Okay? Okay, so now let's do some multiplication. Go ahead and distribute here and here and simplify. You guys know how to do that without me. Go ahead and simplify those. So I have p squared plus 2p squared is 3p squared plus 2p. When I bring this 8 over, if I subtract 8, what's negative 8 and negative 8?
Wait, where'd you get the 3 piece? Where'd you get the 3 piece?
I have p squared and 2p squared.
But you multiplied those, right?
Afterwards, she combined them after she distributed it.
What is p squared plus 2p squared?
Oh, right, okay, yeah.
Okay.
I hadn't combined like terms yet.
Follow along with me. Okay, then we can x factor this, right? So what two numbers multiply to get negative 48 and add to get 2? 8 and negative 6. But can you just set up your parentheses and go from there? Can you just put p plus 8, p minus 6? You got to go the long way. Because you do 3 times negative 16. Okay, so instead of taking a few minutes to factor, I've already factored it for you. Go ahead and write this down. 3p plus 8 and p minus 2. That's what this factors to when you go the long way. What do we do with each of these things now? Oh my gosh. and p minus 2. Okay, so then we're going to go ahead and add 2 across, so that gives me p equals 2. I get negative 8, divide by 3. P is negative 8 thirds. You guys agree with that? Okay, so if we set them equal to 0, I get p equals 2. And now what do we have to make sure of? That it doesn't equal 0 when we plug it in. Pretty sure the fraction isn't. But what happens when I plug a 2 into that first one? If I plug a 2 into p minus 2, what happens? I get 0, right? When I plug a 2 in for p and p minus 2, I get 0. That means 0 cannot be an answer. Okay? So our only answer, we can check negative 8 thirds, and now I will tell you negative 8 thirds is going to work. So negative 8 thirds is going to be our only answer.
Hypothetical scenario. Let's say both answers equal 0.
Then it would be no solution.
Okay.
All right, our last example is going to be number 12. So I want you to look down at number 12, please. Nope.
No.
Because the 4 has a c with it, so the 4c is not a perfect square. So it's c times c minus 4. Right?
Oh, yeah, just common factor, yeah.
Okay, so our LCD is c times c minus 4. Would you agree if I multiply this first fraction by c and c minus 4, it's going to cancel, right? So the first fraction just has a what with it once I clear the fraction? It just stays 3c minus 2, right? Because the top and bottom cancel. What happens if I were to multiply the second fraction by c times c minus 4? What's going to happen here? The second fraction. What's canceling? The c, the top and bottom, not side by side. The c minus 4 is canceled. Right? So this is the same as if you were to write the whole thing out. C minus 4 times c over c minus 4, right? Instead of writing this out and canceling them, we can just do it up there.
So just c remains.
Yes, so just a c remains, but we also have this c right here, right? So I have c times c,
C is just
c squared. What about that next one? That negative 1, if I multiply this negative 1 by c times c minus 4, is anything canceling here?
No, but it changes.
Nothing cancels it, right? So I know that I'm multiplying this negative 1 times, I'm going to put it back in the form, c squared minus 4c. Right, because isn't that what we did originally? I just had factored it. Right, this is the same thing as c squared minus 4c. Okay. So now if we simplify these things, 3c minus 2 equals c squared, and then what's going to happen here? Our signs are going to change, right? So minus c squared plus 4c. Okay, go ahead and finish this one out.
Is it possible that if we treat the 1 as a fraction, could we cross multiply the first two fractions and then cross multiply?
No.
Oh no.
Cross multiplication only works on an equal sign. And these two over here are not, there's not an equal sign separating these two over here. Okay. Alright, so c squared minus c squared cancels, right? You have 3c minus 2 equals 4c. What are you going to do here?
Subtract.
Subtract what?
I was going to subtract the 4c.
So if you subtract 4c, you're leaving nothing. You're leaving 0 over here. Negative c minus 2. So instead, what could we do?
Subtract your 3c.
Yes. So we get negative 2 equals c. What happens when I plug a negative 2 in? You want to be careful because sometimes it might not work. If I plug a negative 2 in, that's 4 plus 8. That'll work. Negative 2 minus 4, that's negative 6. That'll also work. So c equals negative 2 is our answer. Not all of these in your homework are really hard like this. Okay, so I need you just to take them a step at a time. The ones in the beginning are pretty easy. Oh, I didn't give you any hard ones. Well, that was really nice of me. Okay, so you're just going to do 1 through 8. All right, you're going to do 1 through 8 for tomorrow on page 21. That's homework 27, 1 through 8.